Hello guys. So this video is specifically for all production support, application support guys or SRE engineers. In this video, I'll show you how to execute Linux or Unix commands using Python, and more importantly, why we do it this way in real production environments. This is not a generic Python tutorial. This is Python as actually used by support engineers for automation, monitoring, and incident prevention. Everything you see here is done in my personal laptop, but 100% this is something which we generally do in production system as well in a Linux box. Okay, in real production we cannot manually log into servers every time and run commands like df-h or anything. So the problem statement today is, imagine disk usage crosses 80% at midnight. Okay, if you wait for users to complain, it is already too late. So instead we write Python script that automatically execute the Linux command, capture the output, analyze it, and alert us. That is exactly what we are building in this video. So I'm creating a file diskusage.py. Okay, always name your script in such a way that any other team member who is using the same box, by looking at the name of the script, they are able to identify what exactly this script does. Okay, so I'm on my Visual Studio now. So let's start writing. So firstly, I'll import subprocess. Okay, let me explain you why we are going to use subprocess. We import subprocess module because it allows Python to execute the Linux commands safely. We have also option to use os.system, but subprocess gives us control. Like it gives us the command output, error output, exit status. So these are very mandatory for us whenever we write a production script, right? So next, once we are imported this, let's define a function to do our logic. Okay, our logic is to check the disk usage. Let's define it inside a function. That is because if at all we want to reuse this same logic in some other script, we can just use the same function rather than directly writing our logic block. Also, one more important step is we will have to define it in a try and exception block. This is because in production you cannot assume anything. The script which is executing now may not execute in future. The system can behave unexpectedly, there can be a permission change, their commands can fail. So it's always safe to use your commands in the try block, so that if at all there is any failure, at least the script will alert you rather than the giving you the wrong alerts for the uh, system alerts, for example, right? So let's go and start with the logic now. So what basically what we are doing here is we will use the subprocess module and its function run. Okay, so here we will have to pass the command df-h as a list. So what exactly we are doing here is, just like how you use df-h in your Linux box, for example df-h, this exact command you want to execute, but here you will have to pass it as a list parameter. Okay, we have to pass all the command as well as the options that we pass to that command as a list item, right? And then we need the standard output. So standard output, we take it into this variable subprocess dot pipe. So it gives us the standard output as well, and standard error also we will have to take it. Subprocess dot pipe. Okay, and then text equal to true. Why we do this text equal to true? That is because the output what we are getting, we want it to be in a we want that to be converted as a string, so we can parse it. So that's the reason we are giving text equal to true. So once that part is done, the next very important is we will have to check now if the result dot return code is not, if it is, we basically we want to check it is 0. So return code tells us whether the command succeeded or no. Okay, it tells us whether the command succeeded or no. So if it has not succeeded, that is not equal to 0, then what we have to do, we just need to give a print statement here saying error in executing the df command, right? And we also give the standard error, whatever we got, result dot std error, and we have to come out of this, so we give return. So if the command fails, we log the error and exit gracefully. This avoids false errors and helps us debugging, right? So now you have the, in case of execution failure of the command itself, you have handled it. Now execution of the command is successful and you got the output. Now the output will be in this result dot standard output, right? So we will put that into an output variable and then we will print it as it is, print disk usage output, and let's print it as it is. Okay, so we got the output now displayed. The next, in real system, this output could be written to a log file, attached to incident tickets, sent to monitoring system, and so on. But here simply we are just displaying it. Now what we have to do, we have to parse this output line by line. So what we have now is exactly this output. Now we have to parse this line by line and find out which mount is crossing the threshold, whatever we are defining. So what we have to do now is, if for we'll traverse it for line in output dot split lines. So what this does is, this each line by line we will traverse of this output. Okay, and we take mount is equal to, we need the mount point, right? So anything which line dot split fifth. So basically what I'm doing here is, in each of these line, where is the mount? Mount is in 0, 1, 2, 3, 4, fifth column, right? So fifth column, here I'm using the split function. Split function splits it based on the delimiter. So in this case, the space is the delimiter, and the fifth column we take it. So if you can see here, it splits it, and the fifth column we put it into the mount, right? So now what we need to do, if mount dot starts with, so basically what we are doing here is, we have ensuring that the mount is starting with the slash, because we have the heading here as well, right? So we don't want this one, this line to come. So anything that starts with slash, only for that what we have to do now, we have to take the usage of it. How do we take the usage? From that same line again we do the split, and now we need the fourth column, right? And also one more thing I want to do here is, this fourth column you got 0%, so I want to replace that percentage with, what shall I do, I'll just give it blank. So I got it, but this will be in the string, so I convert this into an integer. Okay, I convert it into an integer and I put it into the usage variable. So I split the lines, I take the fifth one. If it is a mount, only then I take the percentage of it. Next condition, if now here comes my threshold, I'll define it as 80. If the threshold is above 80, what I need to do is, for now I'll just give it as an alert. Maybe I'll type it in caps alert, and what we will do is alert disk usage is high on. We will display the mount as well as will tell what is the usage right now, usage, and since we have removed the percentage, let's put the percentage here. Okay, I hope till now it's very clear. So this is the business logic. Thresholds depend on application behavior. Here I have given here 80%. So if you want to define it as a variable and then take it, that is also fine. Or sometimes you may need 70% as a warning and above 80% as a critical alert. You can do that as well. So in real world you can also trigger an email, or you can trigger a ticket. You can create a ServiceNow ticket, or you can uh, uh, send it as a text message as well, or Teams channel. You can uh, give this as an alert. So that depends how you want to handle it, right? So now I'll define the except. Here comes my exception as E, and I'll print the exception. I'll just give as unexpected error occurred, right? And I'll just give that whatever exception I got, I'll have to convert it to a string, right? This is what exactly the script is. This is the final safety net. So anything we get an unexpected error, we throw it as an exception instead of terminating. And finally we will have to give the main block, right? If main, if the name is equal to main, then check disk usage, right? This ensures your script runs only when executed directly. Okay, this is important when scripts grow and get reused, right? So this is very important. So let's now save this script and let's go and execute. So we have our script here, right? So Python 3 and disk usage. I'm sorry. I'm sorry for that. So we have the script here. I entered too early. So this is the output we have. So we don't have anything that is crossing 80%, right, in the mounts. So let's give now 70 just to check if our script works fine, and let's rerun this. You can see here alert disk usage is high on mount D, and that is greater than 70%, so it gives us the 72%. So in the real world the same pattern is used in production support as well, to monitor memory, monitor processors, validate file arrivals, perform any preemptive health checks. So this is why Python is extremely powerful for support engineers. Okay. In the next video, I'll show you how to connect to Python to a database, fetch data using SQL, and generate report automatically. This combination, Python, Linux, and database, is what separates any junior support engineer from senior one. Thank you for watching. I'll come up with the more interesting videos. If you have liked whatever I have taught you in this video, please do like it. Please subscribe my channel, and please support me and comment with whatever feedback you have. It can be positive or negative. I'll try to take it and try to implement it in my upcoming videos. Thank you all. Thank you all for the support.